Prepare yourself. I am a bad Orphean robot. You will insert toy space empty.
Okay, well, we got down to checking our voltage coming off the power supply going to the card cage, and we have some bad news here. Our plus 5 volt is giving us 11.43 volts. The minus 5 volt rail is good. The 12 volt rail is good. But both our wires are supposed to be plus 5 volts, is reading 11.42. So that would mean that we have a 5 volt voltage regulator failure in the power supply. So looks like we're going to be rebuilding the power supply. Well, here we are back with the Bally Midway power supply out of my Gorf, and I've ordered a complete repair kit from Bob Roberts to rebuild the power supply. Everything on the power supply is working except for the plus 5 volt line, and I'm pretty sure that the problem is a bad 2N3055 transistor here. But we're going to go ahead and rebuild the complete power supply when we get the kit. But the kit won't be here till Monday, and here it is, it's Saturday, and I'm just dying to know if this is bad. Then I got to thinking, I said, well, I happen to have some Bob Roberts Atari AR2 repair kits here, which has a brand new 2N3055. So what we're going to do is I'm going to go ahead and pull the 2N3055 out of this power supply, and I'm going to compare it with the new one and find out if this is bad. I got a feeling it's shorted, but I don't know. I'm getting 11 point, I don't know, just shy of 12 volts on the 5 volt line. So it's almost like the regulator is not doing anything. It's just sending all the voltage straight past the regulator. So we're going to try it and see, compare it to a new one, and go ahead and put this new one in and see if that fixes the problem. And then when the kit comes in Monday, I'll go ahead and I'll swap out all the rest of the components, the capacitors, and I even got new pins coming, 90-degree pins, because one of them had a little tarnish on it where it had been heated up, and I'm even going to replace the connectors that go onto the pins. So let's get started. Okay, first thing we did, we took the 2 screws out of here that hold the transistor to the heatsink. So with the screws removed, now all we have to do is unsolder the 2 legs of the transistor. And I hate it when they bend them over like this, but we'll just slide this on, bend it up, and that's loose. And now we can take this transistor off, and the first thing I see wrong is there's no heatsink compound on it. They put it back dry. Never put a power transistor on a heatsink dry unless you're using the type of pad that's it's like rubber. This is a mica, or some form of mica, and this should have had some type of heat compound on it. So that was the first mistake, so that might be what caused us to go bad. Okay, well, let's test these two transistors here and compare them, a new one to the old one. And this is the old one, and this one is labeled. This lead right here is the emitter, this is the base, and of course the case itself is the collector. So let's start by I put the ground on the case, which is the collector, and we'll put the other lead, positive lead, on the emitter, and we're showing 96.2 ohms. Alright, let's do the same thing to the new one. And we're getting nothing, we're getting infinity. So that tells me right there that we have a emitter to collector short. So let's reverse the leads. This time we'll put the positive lead on the collector and on the emitter, the negative. And we're getting about the same reading. We're getting 95.4. And do the same thing on the new one. And we're getting infinity. No, not getting anything through it. So that tells me that this old transistor is definitely bad. So we can go ahead and check from collector to emitter. And on the old one, we're getting basically 1.3 k ohms. Alright, let's see what we're getting on the new one. On the new one, we're getting 8.41 megs. Alright, let's reverse that. Now we'll do it on the old one first. On the old one, we're getting 3.08k, and the new one, we're getting nothing, infinity. So that definitely tells me that this old transistor is definitely bad. So we're going to go ahead and put this new transistor in, and then we'll go ahead and test the board and find out if that fixes our 5 volt on the power supply. Now when we took the old transistor off, it had this insulator behind it and had no heatsink compound on it. It was put on dry. Now, I've never seen one of these before. This looks like it's made out of what they call Kapton, which I know they make a Kapton tape, an adhesive tape that they use on battery terminals, on LiPo battery terminals. But it's a, I believe, a polymer type material that's real stable and heat resistant. So maybe this is meant to be used without heatsink compound. I don't know. But I'm from the old school, so I'm going to replace it with a mica insulator, and we're going to use the heatsink compound. So we're just going to go ahead now and put a couple little dabs on here. It's probably just a little too much, really. Don't really need much because it spreads out quite a bit once you tighten it down. So we'll just go ahead and clean a little bit of that off. And we'll put our insulator on. And now we're ready to install it. So now what we want to do is we'll just put a very little bit of this heatsink compound . Alright, first we're going to clean up the solder pads, and the two pads were right corroded where the collector makes contact with for the screws. So we're going to go ahead and we're going to coat them with solder also, so that the screws, the star washers, have something to bite into, which should help it make connection. That could be what caused it to go bad, is that these connections here for the collector got corroded. I don't know if that would cause it or not, but that's as good a theory as any. Of course, it could just be old age too, since this quite possibly could be the original transistor that originally came in the game. Never know. It is was a Motorola, which you don't find new ones anymore much. Okay, now we just take some solder wick and sort of clean these up. What that does, it leaves a nice coat of solder and cleans it up real good. So it'll make a nice solder connection on the two solder connections, and where the screws go, it'll help prevent it from corroding and give the screw a little something to bite into. Okay, now we can go ahead and put our transistor in. Now these had the screws going in this side. And there it is. Thought I'd lost one of my screws. Alright, turn it over. Now this side also had a star washer on each one. And had a nut on each one. Now we might not have to even hold those screws, since they got that star washer on them. That may tighten up good on their own. And they did, they tightened up just fine. Alright, so now we can go ahead and solder our two leads. And that should do it. Now we can go ahead and put it in the game and try it out. Okay, so we got the power supply back in. We have our ground hooked up on the ground pin. So let's turn the game on. Now we have everything disconnected from the game except for the AC going to the power supply, because if we do have a power problem, we don't want to put any wrong voltages back into our boards. So with that said, let's check the 5 volts and see what we're getting. And I'm getting 5.66. So let's make an adjustment here. And we got it right on 5 volts. Alright. Pin under it should be 5 volts. Same thing. Next one should be 12. And I've moved these pops around, so I'm going to have to readjust these. Wait a minute. See which one is the 12 volts. Okay, pin 7 and 8. Would help if I have it on the right pin. Okay, that's more like it. Yeah, got that right on 12 volts. Now let's check our -5, which is pin 2. And that's a little high because I was adjusting that too. So let's put that back down. And 5.1, that's good enough, -5.1. Okay, now the power supply is not under a load, so when we hook it back up to the board, if everything is running fine, we might have to adjust the levels back up and get them properly, but they should be close enough now for us to hook the board back up and try it out. So let's go ahead and cut this off. Take the ground loose. And this is keyed, so it only goes on one way. But we want to make double sure we got it right. But since it can only go in one way because it's got the key, not a problem. But if somebody had replaced this connector and didn't put that key back in there, you'd have to check your wiring and make sure you're hooking it back up correctly. Alright, well today we're going to get back to finishing up the power supply on the Gorf. I'd already found out that the 5 volts power supply part was bad, and the -5 and the 12 volt were okay, but I decided to go ahead and put a Bob Roberts overhaul kit in it. But the other day I wanted to get the 5 volts going just to test the boards out in the game to make sure that they were still working. So I'd already replaced the 2N 3055 transistor here, and that was the component that was bad in the 5 volts. So after replacing it, I was now getting the 5 volts. And then I found out that I had a short on the 12 volt line once I plugged the boards in. And I found out that that was one of the RAM boards. One of these titanium capacitors had, on the 12 volt filter line, had shorted out, and that was causing my problem on the 12 volt line. But before I found that, I went ahead and replaced the 12 volt regulator here, the LM317. So that's already been replaced. So now all we have to do is go ahead and finish this up, replace the 7905 and all the filter capacitors, two of the pots, this IC, and the diodes. And of course all this is in one of Bob Roberts' 9411 OEM parts power supply kits, which has everything you need to rebuild this power supply except for this one IC comparator chip. It's a voltage comparator, I believe, and it's working, so I'm not going to bother with that. I'm going to leave that on here. Also, because I have a couple of these connectors here had burnt pins and they were a little corroded, I'm going to go ahead and replace them with some brand new 90-degree header pins, and also have the connectors, so I'm going to go ahead and replace those as well. So that ought to get this Gorf power supply back up and ready for another 20 years. Now if you go on Bob Roberts' site, he has a nice little write-up on the Midway 9411 power supply, which has some pictures and parts layout and the repair parts that are in the repair parts kit. So it makes it nice as a little guide to go by for installing his kit. So since we've already replaced these two transistors, we got one left here, the 5 volt, minus 5 volt voltage regulator. We'll go ahead and replace that next. Okay, since I didn't record installing the 12 volt regulator, the 5 volt regulator is just like it. So first thing we're going to do is go ahead and remove the screw that holds it on the board and actually makes contact to the heatsink. It has a nut on the other side. Has a nut and a star washer. Alright, so now that's loose from the heatsink. So now what we can do is take our desoldering iron and go ahead and suck the solder off of these. I don't like it. Somebody has bent these tabs over that. Oh, that makes it a pain in the butt sometimes. I like for the component tab to be sticking straight up so that you can put the hole of the solder sucker right over the end of the component leg. Just makes for a much nicer removal. So now what I'm going to have to do is put this on the edge here and put it under it and flip it up. And the hose is getting caught on the board there. Alright, and let's see. All three of these are definitely loose, and it comes right out. Now, because this one was the negative 5 volt regulator, the doesn't look like it has a insulator behind it, but they did have the heatsink compound on it. So we're going to go ahead and clean that old heatsink compound off and go ahead and mount the new regulator in place. And we're just going to take some electronic cleaner. You can use alcohol or pretty much anything here. Put a little bit on here, and it's got a nice little brush on it, so we'll just brush it around a little bit. And take a paper towel. And I was wrong, it does have an insulator under it. So I guess this one does have to be insulated. Just had so much heatsink compound on there, I couldn't see the insulator. Okay, so we got that all cleaned off. Now we'll go ahead and get us a new insulator and some heatsink compound, and we'll mount this component. Okay, well, we pre-bent the legs and test fit it to make sure that it lines up, and so now we can take our heat compound and we'll put just a little dab here and spread it around. Now we put a little dab on the back of the regulator. Don't need much, because once it tightens up it spreads out. And we take our new insulator. Drops today, and now we'll put it in and line up the holes. And we'll take and put our screw up the washer, goes in the back side. Star washer and the nut. Now, because it's got that star washer on there, I won't have to probably put a socket on that nut. All I have to do is tighten it down, and it should tighten itself. And just snug it down good. And that's mounted. Now we have our 3 leads here. Now what I noticed was somebody had replaced this before, and when they did, they sort of messed up the traces on the board. Let me see if I can get a close-up on this. It still might be kind of hard to see, but the pad around this one right here is almost completely gone all the way around it. That's why they had them bent over. So I cleaned back the copper trace here, so I'm going to go ahead and bend it over on this side, and that'll make a good contact there. This one here on this side is not too bad, so I won't have a problem with that one. But the center one here comes in from both sides, and they took out the trace, the center hole where they connect. So I'm probably going to have to bend it over to one side or the other, and then bridge a little piece of wire or some sort of braid, something to make sure I get a good contact between the two. So let's go ahead and do that next. Okay, this one I was able to bend right in line with that trace, and this one I bent over to this trace, and this one I bent to the side, so I'll be able to get a good contact on both sides here. This one right here is going to be the problem, because there's nothing making contact to this. I could just bridge a piece of solder across it, but I'm not going to do that. We'll add a little piece on top of this and have it come over closer to it to bridge it across. So let's go ahead and first we'll I'll put just a little bit of liquid solder flux on here. And we'll take our soldering iron. And first let's go ahead and solder this one here. And get the one on the other side here. Now we get this one. Now let's get something so we can bridge that over. Okay, we've taken a little piece of solder braid or solder wick, whatever you want to call it, and went ahead and let it absorb some solder, and now and cut it down to size. So now we're just going to lay it right on top of that trace. And then we're going to take our soldering iron here and try to flow the solder and just let it flow right into it. Let it cool down a little bit, then we'll go to the other side and we'll hit that side and let it flow back, and you can actually see it melt all the way back to the other side. Alright, so now that's bridged these two traces, and we have a good clean joint to where we don't have any solder bridges between the other two leads. So that should fix that. Okay, next we're going to go ahead and replace the two pots that came in the kit. Now there are 3 pots on the board. The 2 pots that come in the kit are for the plus 5 volts and the minus 5 volts. There was no pot in here for the 12 volts. I don't know why, but I do know that it was working okay, as well as these other 2, but since they're in the kit, I'm going to go ahead and replace them anyway. So we'll go ahead and flip this over and unsolder both these pots and install the new ones. Now these pots are a little different than most. They only have 3 physical connections, but they actually have 4 solder connections, because what normally on a pot has the 3rd center leg on it, this one only has the 2 outer legs, and the center leg is incorporated in these 2 outer pieces that help hold it to the PC board. So because of that, and they're so wide, it can be a little bit different trying to desolder them. So what I'll do is I'll desolder the 2 outer ones first here. And that way I'll be able to grab onto the pot from underneath, and I'm going to soak up a little bit of the solder here from the edge, and I can pull it right out, and it comes right off. So I'll go ahead and do the other one just like it. Okay, I've cleaned up the solder pads, and now we'll go ahead and stick the new pots in. These are sort of bent so that when you stick them up in the hole, they kind of hold themselves in. So let's go ahead and pop these in place. Okay, so we got them in place. So now let's go ahead and put some solder on them. Now, the center, one solder pad makes the actual connection here on the board. The other one is basically just to hold it in place. So we'll start with that one. And then we'll go opposite. Do this side. And we'll come back and do this one. And now we'll do this one. Alright, one down, one to go. Okay, now both pots are installed. Okay, well, what's next? I think what I'll do is go ahead and we'll take all the electrolytic capacitors off the board. That way, with them out off the board, out the way, we'll go ahead and be able to change these diodes, and then we'll put the capacitors back on. So we'll start by just clipping the tie wraps. That's holding these on. Removing them from the board. Now we'll go ahead and unsolder the leads. We don't have to worry about marking the position of these because these are electrolytics and they do have a positive side and a negative side. And then while they're not marked on the top side of the board, they are clearly marked with the plus signs on the board, and all the diodes are actually marked so you know the direction that the diodes go back in. So we won't have to worry about marking the boards. We'll just go ahead and desolder them one at a time. And there's one. And I believe my desoldering gun is plugged up, so we're going to have to clean that out. Okay, we're back in business. Another one down. Another one. One more to go. Alright, that's all 5 of the caps. So next, we'll go ahead and sort out the diodes here, and we'll figure out which one goes where, and we'll go ahead and we'll replace those in groups. Like if these 4 get replaced, we'll do those, and then we'll do these, and these 2, and these 2. So let's find out what's in the kit, and we'll do that next. Okay, so we have the diodes all laid out. These 4 right here are replaced by these 4. These 4 right here are replaced by these 4. These 2 right here are replaced by these 2. And then we have these 2 right here are replaced by these 2. So we'll go ahead and we'll just start right up here, and we'll take and desolder all 4 of these and replace them. And these all go in the same orientation. The band goes on this side here. So let's go ahead and desolder those. Okay, let's go ahead and desolder these first 4 diodes. There's the first one. This thing stopped up again. Alright, let's see if we can finish this now. got all of them out. These diodes have such thick wires in them, they're about the same size as the hole, so they're a little tight in there. Even when you set the solder off, the solder still wants to stick around them because they're basically the same size as the hole. So alright, we'll go ahead and we'll clean these traces up. They look pretty good, and then we'll go ahead and we'll solder in the new diodes. Okay, well, the first thing I like to do is I like to go ahead and pre-bend the leads, and these are pretty thick leads, so they're pretty heavy-duty diodes, so they tend to stay in shape pretty good. Okay, orientation on the board. The band is going to go on this end on all four of these, and of course you can always take a before picture, but if you turn it over and look on the board here, you can see the little representation of the diode here, and you can see that the line is on this side, so that means this side is where the band goes. So with that in mind, let's go ahead and put these in, and we'll just put them in and push them down. Okay, and to hold them in place, I usually just take a piece of electrical tape and that'll hold them down on the board while we solder. You can also, if you like, put something underneath here to prop them up. If you don't want to use tape, you can always just put something under there to support them. Whatever works for you. So now we'll just take our soldering iron here, and I'll solder. First I'll give it a little dab of some liquid flux. Although I don't anticipate any problems with the solder. The pad's cleaned up real good. Okay, so let's go ahead and solder these. Get a nice good solder joint on them. Make sure you put your tip both flat on the pad as close as you can, and also get it on the component leg. Let it heat up a little bit and then apply your solder. And then I like to move it from side to side, and you get a nice shiny solder joint that way. And when I'm doing components, I usually don't go from one side of the component to the other. I let it cool down a little bit, so while it's cooling down I'll go to another component on the board if I got more than one component. Then I'll go back to the other one. And looks like we got good solder joints on those. And we just take our side clippers here. And take our tape off. And those are done. Now we can move on to the next batch here. Now these 4 are all the same type of diode, but if you notice the orientation, the band is on this side on these 2, and the band is on this side on these 2. And of course it's marked on the other side of the board, in case you're wondering. But, so what we're going to do is, so we don't get mixed up, we're going to go ahead and take the first 2 off and replace those, and then we'll take the next 2 off. That way we know that these 2 are opposite of these 2, so we can just look at the other 2 that's still on the board and tell which way they go. That way we won't get mixed up. You definitely don't want to put them in backwards, because, and same thing with the electrolytic capacitors, because if you get the positive and a negative backwards, when you apply power to it, something is going to go boom, pop, or fry, and you definitely don't want that. So, let's go ahead and take these first 2 off the board. Just basically fell out. Both of them just fell out. Okay. So let's go ahead and get 2 new diodes. And these are the smaller ones that are in the kit. And go ahead and bend the leads over on them. Don't have to be exact, because they will bend into it a little bit, but you can get them close by eyeballing them. Okay. Now, if you remember, they're opposite of these 2, so the band is over here, so we'll put the band back on this side. So let's go ahead and stick these in. And prop this up on something in a second. And we'll get a piece of electrical tape. And we'll tape those down. A little dab of flux. And we'll solder them in. take the tape off of those. And now let's go ahead and desolder the next two. Basically fall out too. Alright. Two more diodes. I'll go on and bend them. Okay, now if you remember, these go in opposite, so we'll put the band on this side. And we'll take a piece of tape. Alright, two more done. Okay, now we'll do these two here next. And if you look, you'll notice the band is on this side, on both of them. And if you can see on the bottom here, they have the band on that side. So let's go ahead and unsolder them. And it's loose, but it's still got a little bit of solder on it. So a little bit of heat can help finish bringing it out. Let's see how this one is going to do. these pads have already got enough heat from just being in operation. You can see that they were already burned just from getting hot, and that, I'm afraid, is already started to lift the pads from the board, but the pads are intact, so they should be okay. They're not torn or broken. They're just coming loose from the I guess that's fiberglass board from the heat, but they should be fine. So we'll just go ahead and stick the new diodes in there, and shouldn't have a problem with it. Okay, well, I pre-bent these so that they line up in the holes here. The band goes on this side. So we'll stick them in. And we'll take our piece of electrical tape. Hold them in place while we solder. A little dab of liquid flux. Clip them off. And we're done with those. Okay, now we're down to the last two diodes, so we'll go ahead and get them off the board. They're both loose. So let's take our last two diodes. Bend them so that they fit in the holes. Alright, let's pick back up where we left off yesterday. My camera ran out of memory and the battery went dead, so I had to charge it back up. So we're putting the last 2 diodes in. So we're just bending the leads so they'll fit. And now we'll put them in. And of course they're marked on the board, so the band on the diode goes on this side. Alright, got a little piece of electrical tape to hold them in. A little bit of liquid flux. Should take care of that. Clip them off. And pull off the tape. And we're all done with installing the diodes on the board. Okay. Next, before we install the capacitors back on the board, might as well go ahead and pull this IC chip off and go ahead and install that. Okay, next we're going to remove the LM339 IC right here. So let's turn it over, and there it is right here. So let's go ahead and desolder the legs on it. And look at that. The chip just fell right out. Alright, we'll go ahead and install the new chip, and we'll make sure we get it in the right way. The little notch on this end goes towards this side. So let's go ahead and put it in. And take a piece of electrical tape and hold it in place. Now we can go ahead and solder it in. And when soldering a IC chip in directly like this, I like to take my time and make sure it cools off a little bit. You don't want it to get too hot. And it looks like it's pretty good. Of course, I didn't put any liquid flux on it that time, but the terminals were all clean looking, so it's not really necessary. There's rosin in the rosin core solder, but usually I put some on there, but that time I didn't, but oh well. Anyway, that one's done. So now let's decide if it's time to pull the tape off here. To go ahead and put the capacitors on now, or to go ahead and change these terminals right here, the header pins. I think I'll go ahead and I'll put the header pins and go ahead and change them before I put the capacitors on. And we'll leave the capacitors for last. Okay, let's go ahead and see if we can unsolder these header pins. A lot of solder on these, so I'll probably have to stop and clean the gun out once or twice. Alright, now let's see how we've got these appear to be loose any. Well, first one is loose and came out. And this one appears to be loose too. Alright, well, that wasn't too bad. Alright, before I do this next one, I think I better clean my gun out, because I'm sure that's quite a bit of solder, and it works better when it's clean. So let me do that and we'll be back and do the second one. Okay, just wanted to show you, that's the solder that I cleaned out of the gun just from those hitter pins. Had quite a bit in it there. So let's go ahead and do this last set. Alright, let's see if we're lucky with this one as we were the other one. And yep, they just drop right out. I tell you, that's the best investment I ever made, was a desoldering station. If you're going to be doing a lot of this kind of work, you absolutely must have one. So I'll show you mine in a second here and show you what I'm using. Okay, well, here it is. This is what I use for desoldering. It's a blackjack made by Solder Works. It's a BK4000 desoldering station. It has a controlled temperature knob here, so you can set the temperature. It doesn't have a digital readout for the temperature, but that's okay. I got it pretty well dialed in to where I need it. And of course it has a built-in vacuum pump, and here's the tube that goes up to the gun, and of course here's the electrical connection for the heater element. And then of course we have this handheld solder gun, and it's of course got the hose on it, and the little chamber there where you open up to clean it out. So it works very nice. I mean, it's not a I don't remember what I paid for it. It wasn't real expensive, but it's not exactly what you'd call cheap, I guess. But as far as equipment of this type goes, it's fairly reasonable. And of course I got a Weller WESD51 digital soldering station, and that does have the digital readout, and it's very nice soldering iron. And like I say, if you're going to be doing this kind of stuff, don't skimp. For years I used Radio Shack stuff, which did the job, but it didn't hold up very well. So, and of course I never could use those handheld solder suckers. Just something about them I just never liked. I know they're simple and if you get the technique right, it works good. But I really like this setup here. So anyway, let's get back to our board here. Okay, first thing I want to do is I always like to take my desoldering brad or solder wick, whatever you want to call it, and let's see if I can do this so you can see it. I like to clean up the pads a little bit, and that's just a matter of heating it up and sliding it over the pad, and it cleans any of the old excess solder off. And it just makes for a nicer solder job when you go to install whatever you're installing. In this case, our header pins. So basically getting all that old solder off and cleaning it up. And of course the solder sucker did such a good job, there's not much on here, so a lot of times you're basically just going over it, and basically just a cleanup. Some would probably say it's unnecessary. Like I say, I'm not professionally trained at board repair or any of this. I'm all self-taught. So you probably occasionally, you professionals out there, might see something that you scratch your head and say, why is he doing that? Well, it's just my way of thinking. May not be necessary, but it's just something that I've done, and it just works for me, so I figure why stop. So now we have all those terminals all nice and clean and ready for the new terminals. Now, the new terminals, we got these from Bob Roberts. Of course, you can get them from other places too. Probably Great Plains would be a good place to get them. And I'm sure you could probably get them from any of the major places like Mauser or DigiKey or whatever. But it was just simpler. I ordered this, had to order the parts kit from Bob Roberts anyway, and he had these, so went ahead and got them. Now, these are, I think they're 24 pins. I didn't really count them, but I think that's what they are. And they're what they call break-off pins. They're attached on each side by just a little piece of plastic, and they're a little flexible. But what you do is you just, however many you need, you just count them off, and then you just break it off. So that's what we're going to do now. We're going to go ahead, and the old ones here were set up in a total of 4. You got one here, and one here, and one here. So we're going to go ahead and get these pins out and break them off to the size we need and get them ready to solder. Okay, well, I've already cut and installed the new header pins, and I've taped them on the board so that they're sitting flat against the board and flush. So now all we have to do is go ahead and solder the header pins on. So for this, I'm going to go ahead and apply some liquid solder flux. And we'll go ahead and solder these on. Now, what I'm going to do is I'm going to solder the one on each end of each one. That way they'll be sure to hold in place, because I don't want the tape to come loose on any of them before I get to them. Now these, you want to make sure you get them hot, but you still don't want to get them too hot. And you want to make sure you get plenty of solder on them, because even though hopefully we're not going to be pulling them off and on very often, but you best have it enough on there to give a good physical contact. Alright, now that we got the end of each one soldered on, I'm going to go ahead and take the tape off. Because what I want to do is check it and make sure that they're all flat. You want to make sure before you go ahead and solder the rest of them, in case you, for some reason, maybe the tape slipped and you might have to reposition them. And they look fine, so we can go ahead and finish soldering them. Okay, now we'll go ahead and solder up the rest of them. Okay, well, that does it for the header pins. Next, I guess, only thing left is the capacitors. Okay, well, we've basically laid out our capacitors. There's 5 electrolytic capacitors, and because they don't make the axle capacitors for these 2 values anymore, they substituted a snap-in type. So what Bob did in the kit is he provided some wire, red for positive and black for negative, to solder onto the leads to run from the capacitor down to the places on the board. The kit also provided the tie wraps to tie wrap the capacitors onto the boards. Okay, we're going to start with the 470 microfarad at 16 volts. This one goes in these 2 holes right here. The positive side is right here, and the positive side on an electrolytic capacitor is always marked. You see the black line here and the arrow pointing this way. That means this is the negative side. The positive side is usually always the end that has the little indented end in here. So anyway, it goes right here. So what we're going to do is we're going to put it in. We've already pre-bent the legs, and I always like to bend the legs so that you can read the value and see the polarity. Just a little something I like to do when I install caps on a cap kit, whether it's a power supply or a monitor. Doesn't really matter, either one. Alright, so we'll flip it over. Go ahead and solder these leads. I don't think we need any liquid flux on them. They're nice and shiny. That's one down. Okay, well, you get the idea of this, so I'm going to go ahead and skip ahead, and I'm going to go ahead and put the other 2 on here, and I'll come back when we get ready to put the other type on with the wire leads on them. Okay, well, let's start by installing the 10,000 microfarad at 35 volt capacitor. And this is the old capacitor. As you can see, it's a electrolytic, and it's rather large for its size. This one is a radial. Both positive and negative leads come out of the end, and the old one went right here. Yeah, negative goes here and the positive goes here. So what we're going to have to do, and it came in the kit, we got red wire and black wire to run to the capacitor. So I've cut a piece of wire here, and this is going to go into right here where the negative lead goes, and the capacitor is going to be mounted on the board with a tie strap right like this. So this will turn and come back up and solder onto the negative lead on the capacitor. So that's what we're going to do first, is we're going to go ahead and solder this negative lead on the capacitor. Let me turn it around so we can see it here. And that's all it takes there. And of course this is going to bend back around and go in this hole right here. Now we need to attach a red wire onto the positive side, and that's going to go to this hole in the board right here and solder on the other side. So we'll put that there. Let's measure a piece of wire, and that should give us plenty. And we'll strip both ends of the wire. And we'll go ahead and tin the lead that we're going to solder onto the capacitor. And we're going to leave the other end with no solder on it because it'd be easier to go down in the hole in the board, because the wire is about just a little bit smaller, and if you put solder on it, it might not go down in it. Alright, so now we're going to solder the positive wire onto the capacitor. Now all we have to do is stick these wires through here one at a time. The negative goes in here. You gotta make sure your wires don't fray and stick out. You want them all going through the hole. Okay. Now we'll go ahead and solder this wire. Okay, looks good on the other side. So now we'll stick the positive lead here. And we'll solder it. And we'll just go ahead and clip off the excess. Okay. Now all we have to do is go ahead and put our tie wrap on here. Now the tie wraps that came in the kit were a little too wide. They don't want to go in the hole real easy. I could probably force them in, but I'm not going to do that. You could probably ream the hole out or drill the hole out a little bit. but I got plenty of tie straps, so I'm just going to use a couple of smaller ones. And let me see the best way to do this. I'm going to have to put it through the board because I'm going to have to put two together. Okay, that one is done. So now all we got left is the 22,000 microfarad capacitor, which is going to go right here. And that one was even a bigger capacitor, the original one, which went right here like that. So the negative lead goes here and the positive lead goes here. So we're going to have to do the same thing, make a longer negative wire to solder direct to the capacitor, and of course we're going to tie strap it right there. Yeah, it'll probably be the best. Tie strap it right there. So let's go ahead and cut the wires for that. Okay, since we're going to mount it right here, and the hole is right here, we're going to need enough wire to bend around about right there. And same thing as last time. Go ahead and strip both ends off. Go ahead and tin one end with solder. And we'll do the same thing here on the capacitor. Tin the negative lead. Of course, the negative lead is the one where you have this band with the minus signs on it. Okay, that's done. Now we have to measure for the positive wire. And since we're going to mount it right here, and this is where the positive wire goes in, get a little bit of slack, cut it right there. Same deal. Take the insulation off both ends. Go ahead and pre-tin one end. pretend lead on the capacitor. And solder the wire on the lead. Okay, now just like before, we'll start off with the negative. And now the positive. And we'll clip off the little excess there. And all I have to do now I made that a little long, but that's okay, it'll work. And all we gotta do now is put our tie wraps in here. Alright, that should do it. Now, the only thing we have to do now is put it back in the game, hook the AC plug back up to it, and go ahead and adjust the two pots to -5 and a 5 volt since we put new pots in, and make sure we got our voltage back on. Also, we need to replace the connector on the end of the wiring harness. Since we put new pins on, we don't want to stick the old wire plugs back on. So the next thing we'll probably do is go ahead and go over to the cabinet and go ahead and put these new wire ends on. Okay, now we're going to get around to replacing the plug on the end of the wiring harness here. We've backed the cabinet up here to our workbench so we can get to it easily. This is the 12-pin plug that goes on the top edge of the connector on the power supply, and this supplies the AC voltage to the power supply. And one pin, if you can see right there on the end, is turned brown where it's got hot and sort of burnt to a crisp there. It was still working, but since I put new pins on the power supply, I figured I'd go on and put new connectors and on the wire there. So what I'm going to do is, the largest connector is the DC connector, which is a 19 pin. So I ordered some 19 pin housings, and what I'm going to do is I've marked it. This one here that I'm going to replace is a 12 pin. So I'm just going to take one of my 19 pins, and I've marked it here where I need to cut it. And I can just take a razor blade or a razor knife, and we'll just whack off the part that we don't need. And the pins I'm going to use to replace it with, the original pins only made contact on one edge of the connector. These connectors are square pins. See if I can get the camera to focus in on it here. Now, don't want to focus real good there. But anyway, they're square pins, and here are the connectors that's going to go into the housing. Okay, there we go. As you can see, this type of pin makes contact on 3 sides of the square pin, where the old connector only made contact on one side. So these are much better type pins, and shouldn't have that problem with the pins burning like the old ones there. Alright, we're taking this 19 pin housing and we've marked it off where we need to cut it, because we need to turn this into a 12 pin housing. So take a double-edged razor blade, put it right here, and try to keep it straight as you can, and just rock it back and forth. And it don't matter if you get it a little bit off, because you can come back, at least on the other side, because you can come back and trim it down. Okay, and there we have our 12 pin housing. So now what we need to do is, before we do anything, we're going to put a key in. Now, the wiring harness here has a key so that you can only put it in one way, and that key is 1, 2, 3, 4, pin number 6. So what we're going to do is, we have us a new key, and put it in number 6. And that way we won't get confused as to where it's supposed to be. So now all we have to do is start taking our wires apart one by one and putting the pins on. Okay, I'm going to start with the pin that was burnt in the original housing, and we're going to keep it pretty close to the original housing, And we're going to clip the wire, but we're going to leave just enough to where you can see the color of the insulation. Okay, first let's go ahead and put a crimp on the wire here. Strip the insulation off of it. And this has got some mighty thick wire here for these connectors. So let's see if we can get one to go on. Load up the connector and the crimpers. And crimp it. Now I know a lot of people, including the manufacturer of the crimps, will tell you that a good crimp isn't going to come off, and this is true, and this probably won't, but call me crazy, whatever. I always like to reinforce my connectors with just a little bit of solder. Not much, but just enough. If you put too much on there, you get the solder down into the wrong spot, and it'll interfere with the crimp itself, with the compression of the crimp. So I just a little bit of solder and just let it melt in. And after that cools down, then we'll go ahead and crimp where the insulation goes. And we have our first crimp. So now, take our new housing and make sure we get the orientation right, because we have our keyway there. And we'll go ahead and insert the first wire. And it locks in place. So, first one down. Let's go to the next one. Okay, well that was the last wire. Here's the old one, and they're all matched up. So we now have a new connector on the AC power input. So now we can go ahead and do that DC connector. Okay, well next we're going to do the 19 pin or the 19 connector plug that is for the power supply DC output. And we've pulled the cable loose where it's strapped down in the cabinet, so that we can pull it out the top side of the cabinet here, so we get access to the workbench. And the main reason we're changing this one is that while it doesn't have any burnt connectors, it does have a very corroded connector here on one of the 5-volt lines. It's actually turned, got sort of green looking goop inside it, and it was all over the pin. So we're just going to go ahead and got a new 19 pin housing, or 19 connector housing, and plenty of pins. So we're going to go ahead and do the same thing we did with the other plug. Take and cut these loose one at a time, put a new plug on them, and put them in a new connector. And we'll do that next, and that will leave us with one other connector, and that's the connector that goes down on the card cage itself. So let's go ahead and get started with this one. Okay, this one also gets a key right in this pin right here. So we have a new key here. So first thing we'll do is we'll go ahead and stick that key in place. And we won't have to worry about that. Yep, got it in the right one. So now we'll just start, and we'll go ahead and we'll start down this end down here. Just as good a place as any. Clip the first wire. Strip off the insulation. And go ahead and load up connector. Insert the wire. Crimp. And I'll go ahead and crimp the insulation too. With this type of insulation, it seems it doesn't make a difference. So I'll go ahead and crimp it now. And I still like to put it in my helping hands here. And go ahead and solder the connection. All right. Now, make sure we get the right end here. Goes in the one on the end. And stick it in the housing. That one's done. Now we just got to do the rest of them, and each one just like we did that one. Okay, well, now we got this connector all done. So we've got a brand new connector there. So now the only one left is the one down in the cabinet. Okay, well, we've pulled the wiring harness apart, clipped some tie wraps so that we could get this cable out of the cabinet. And this is the power cable that goes to the card cage. And as you can see, it also has this green corrosion on that same 5-volt pin. So we're going to go ahead and replace that. And we have some connectors for that already. We don't have to cut one. These are 9-pin connectors. So I have some 9-pin connectors here. And this one also has a key in it. So we're going to go ahead and stick that key in it before we get started. Alright, so now what we're going to have to do, same thing we did to the other 2 plugs. Clip each wire off individually and put new connectors on. And the reason we separated this out of the from the harness is because we want to be able to get the card cage on the workbench, because we have a pattern board in the card cage that's going bad. It's giving us a graphics glitch, and I can't find any working pattern boards anywhere. Everybody seems to want an arm and a leg for their boards right now. There's 2 sets on eBay, and they want $185 for a board set that's untested. Now, I might consider it if it was tested and working, although I bought my last set that was tested and working. I think I paid $110 for it. So I'm just going to go ahead and set this up. Since I have it up here to the workbench, I'm going to put another card cage up here and plug it up, and put the pattern board in the open faced end of the cage, and see if we can do some troubleshooting. So this is the last connector, and after we do this, then we're going to get into some troubleshooting. Alright, well, this is just like before. We're going to take and clip the wires one at a time. Strip the wire. Load up a pin in the crimper. Insert the wire. Crimp it. We'll crimp the strain relief. And solder the connection. Now, take our new housing, and insert the pin in the housing. And all we got to do is do the rest of them, and we'll be finished. Alright, well, we just finished up the last connector, and it looks good. So now we can go ahead and put the power supply back in the game, and hook it back up and adjust the voltages, and confirm that the game is up and running again. And then we can go ahead and start on the next project, which will be to repair the pattern board. So we'll have to fix our spare card cage up here on the workbench and get all these wires in the cabinet to connect to the cage, so that we can have access to the board while the game's running, so that we can take a logic probe and try to figure out what's wrong with that pattern board. Okay, well, we have our power supply back in the game, and we have our AC power connector hooked back up. And before we hook the DC connector back up, which powers the game board, we're gonna test and set the voltages at the proper voltage. And we have our ground connection here for our voltmeter, which is on can be on either pin 13 or 14. So now let's go ahead and power up the game. Cross our fingers and hope we don't see any sparks and smoke. Alright, the first thing we're going to do, we'll go ahead and test the plus 5 volts, which is probably one of the most critical because that's the 5-volt logic for the power to the board. And we can test the 5-volt on pins 18 and 19, which are the last two pins on the top side here. So let's go ahead and put it on here and see what we got. Okay, we're still working on this Gorf power supply. Now, when I first got started on this, my 5 volts was the problem, and I changed to 2N 3055 transistor, and I got my 5 volts back, and everything was working fine. But I'd already ordered a Bob Roberts repair kit, so when I got it, I went ahead and installed the capacitors and the diodes and the pots and the other IC that was in the package along with everything. And after I installed everything, even changed the header pins, put it back in, and I'd lost my 5 volts again. And the 5 volts was working before I went ahead and put the kit in. So I got tracing back and looking at the schematic, I'm getting 13.7 volts on the collector of the 2N 3055, but I'm getting nothing on the emitter, which is the output side, and I'm getting nothing on the base, which is connected to pin 10 of the SG3532 chip. This, I guess, is the voltage regulator for the 5-volt section, from nearest I can tell. And in order for the 2N 3055 to turn on to get power to the emitter, you have to have a voltage applied on the base, and I'm getting nothing out of pin 10, which is connected directly to the base. So I can only come to the conclusion that the SG3532 chip is bad. Well, luckily I found a source, and I have one here, so I'm going to go ahead and put it in, and we'll find out if that's the problem. Now, I don't know what would have caused it to go bad, since it was working prior to installing the capacitors and the diodes, but maybe it was just on something weak about it, and it just decided to let go. So we'll go ahead and change it out and find out if I get my 5 volts back or not. Okay, well, I've soldered in the new SG3532 voltage regulator chip, and I don't believe the old chip was bad. I think what happened after I unsoldered it off the board, here's the old chip right here, as you can see, it has a leg broke off. Well, that leg was actually bent straight up in the air and had this resistor was soldered to it, and evidently it had gotten bent one too many times, and that leg had, I didn't know it, but had broken off, and because it was soldered on to the existing portion of the leg and it was close to it, I couldn't tell it had broken free. But after I unsoldered it and I soldered the other leg of the resistor to take it off, it just fell right off. So pretty sure that because that leg had broken off, it was keeping this from working. So got the new one in, so we're going to go ahead and slide it in, and we'll find out. Cross our fingers. Okay, well finally we've got the power supply back in the game, and I'm confident this time that we have everything ready to go. But only one way to find out. Let's power it up. That's a good sign. Always a good sign when you don't see any sparks and flames and smoke. So first let's go ahead and check our 5 volts, which is on pin 18 and 19, which are the last 2 pins on our DC connector here. Alright, we got 5.25 volts, and of course I haven't adjusted the pot yet. So that was our problem, was the lead had broken off of the 5 volt voltage regulator chip. So now we'll adjust to 5 volts. Five volts on the nose. Okay, now that we got our 5 volts back, let's go ahead and check our 12 volt and -5 just to make sure we have those dialed in. They should be okay though. And pin 7 and 8 is the 12 volts. So we're keyed at 6, so right above the key should be 7. Getting 12.04. So we'll just dial that back a little bit. At 12.02. We'll leave it there. And our -5, which is on pin 2, is down near the bottom. And we're getting 5.06. And I believe this was always a little bit above. I don't think it'll go any lower. No, it'll go higher, but that's as low as it'll go. 5.06 minus. So, but that's fine. That's within specs. So, okay, we finally have a working, rebuilt power supply with new connectors and everything. So, I was about to pull my hair out on this one because I knew I had 5 volts before I finished putting the diodes and the capacitors in, and that leg breaking off of that regulator chip kind of threw me there because it was in a position where I couldn't see it. But anyway, next thing, this is done. So now we're going to have to go back and try to figure out how to get this card cage. I have a spare card cage. What I want to do is get the wires out of the cabinet far enough so I can hook up a spare card cage so I can troubleshoot the pattern board, because I have a bad pattern board. So till next time, till I get that set up and we start troubleshooting the pattern board, that's all from the arcade today.